Hello and welcome to this episode of T-Tech. On today's episode, we'll be discussing the basics of computer networking. I do hope you enjoy this one, and let's get into it. Hello and welcome to this episode of T-Tech. Today we're going to be discussing the Open Systems Interconnection Model. So the OSI Model is the framework for how we understand and visualize networks. So when we're designing a network, we use this to find out how it should fit together, things like that. So it's 7 layers, and from the top to the bottom, they are application, presentation, session, transport, network, data link. Now the data link layer does have 2 sublayers, the MAC layer and the LLC layer. That they stand for Media Access Control and Logical Link Control. Now the last layer is the physical layer. So now we're going to go down each layer and discuss how they operate. Now you will notice as well, the layer below in the model from 7 down always provides a service to the layer above. Alright, so the layer above doesn't know anything about the job of the lower layer. It just sends its information down. And you'll see this by the time we're done. So, the application layer, what does it do? Well, this is layer 7. So, you have protocols that work here. Now, these protocols are not things like applications. The protocols are used by applications, but you don't actually interact with them directly. Like, for instance, I'm recording this with a screen recorder. It isn't part of these protocols. Like LibreOffice isn't part of these protocols. But anyway, they are rules for how these applications should interact together. Now, you have examples here. HTTP. If you look right up here in your bar when you're watching this video, you'll see HTTPS for YouTube's website. So right there you see an example. Your web browser is communicating using HTTPS, which that just means it has encryption, but we'll get to that in one second. So that is some of the protocols that work there, and something called a port number, and you'll notice what that is in one second. So layer 6, the presentation layer, its job is to format those protocols. So all these protocols here, they have to be represented in a standard way. So the presentation layer formats these as ASCII, among many other things, but this is the main one. The presentation layer is also responsible for encryption and decryption of information. That just means we can hide information using either public and private keys or one key. But that is how we would do that there and what that layer is responsible for. But going down to the session layer, that is layer 5, and this manages the protocol's connections. So everything like HTTPS, Telnet, all those things, it manages starting them and stopping them, making sure resources are available for them, and things like that. Layer 4, this is where things start to really get interesting. This is the transport layer. Its job is to send data between ports. Now those numbers at layer 7 we saw to the right of the protocols, those were the port numbers. And the port numbers identify the protocol with the client software like Firefox and the web server. For instance, there's many other clients and servers to use for different tasks, but its job is to send the protocol information as segments. So it segments it up, and it wants to put a port number, a source port number, and a destination port number to identify that connection between the client and server. So there's 2 protocols here. We have TCP, the Transmission Control Protocol. It gives us a way to reliably send that information. So it can do things like find out if it's lost information in that connection and resend it. It also controls connections and things like that as well. But we also have a lighter weight version of it. called UDP, or User Datagram Protocol. And UDP has source port and destination port numbers, but it doesn't have reliability in the sense that it won't watch out for if it lost information and retransmit that. But those are the main ones, by the way. There is many more things at all of these layers, but there's just so much that you got to boil it down a little bit. So again, of course, we have our port numbers there. We figured that out. And our connection setup and teardown is managed by things like TCP and other protocols. So there's the transport layer. And now we're going to go down to the network layer. This is layer 3. Now layer 3 is all about routing between networks. And the networks we're talking about are IP-based networks. So we're using our routed protocols. Those are protocols like IP and IPv6. Those are two examples of routed protocols. And what a routed protocol is, it just means it has information in there so routers can figure out where to send it. That's all that means. And in this case, we also have other things like ICMP, that's for debugging and things like that. And IP addresses are what these routed protocols use to figure out where to send their packets. Because at layer 3, these are packets. So the routing table as well. Your computer has a routing table, and even your Wi-Fi router has a routing table to find out where to send your packets. So even just to get to YouTube to watch this video, your router is using its routing table, and your host is using a routing table as well. So routing protocols send information of networks that routers know about between each other. Because in bigger networks, like the internet, you have to have a way to tell everyone what networks you're connected to, so everyone can converge and know where to send all that information. And also, it can recalculate that if a route fails. So when you hear a lot about dual WAN at home networks and things, enterprises, that's one of the things you can use is routing protocols for that. So layer 2 is our data link layer. And at layer 2, we want to send data link to link. So this doesn't use IP addresses. This uses mostly MAC addresses. And there's different protocols. You've heard of Ethernet, and that is 802.3. That's the IEEE standard for that. But there's also other protocols here. There is DSL, or digital subscriber line. There is DOCSIS for your cable modems. There's 802.11, your Wi-Fi. We're all familiar with that. And there is also cellular methods. There's 3G, 4G, LTE, and now newer ones are 5G that's coming out now. But the main addressing we use here is MAC addresses. And the main thing to remember is layer 2 is where computers are communicating directly with each other. The logical addressing at layer 3, that's where networks of computers are communicating. That's why we have to have IP addresses, so the routers can send that traffic across different networks. Something critical to understand about layer 2 is if you have a router, and you have a router like with your Wi-Fi router, from your Wi-Fi router, if you connect to your wireless of it, or to the LAN ports on the back, that is one layer 2 broadcast domain. So that's one LAN, in other words. But the only way you can get out of that LAN is with those IP addresses and the router. So that has to send across at layer 3. So that's why layer 3 is depending on the data link layer to send between computer to computer, but layer 3 can also route those transport layer segments that we talked about before. So, lastly, we have layer 1, which is the physical layer. The whole job of this layer is to send bits as signals. So it has to find a way, because in computers you have binary. Binary is just ones and zeros. Well, we can't just send like the port numbers right over the line, say this is port 80. It doesn't work that way. It's represented by a series of ones and zeros. And the computers on the other side know that, and they're able to take that and figure it out from there. but it sends bits represented as signals between computers. And it moves data over a distance. That's very important to understand because layers 7 through 2 take place inside of the computer. So that information is not physically moving a distance. Now, this next one is a modulation. That's what we said. It's taking those ones and zeros, and depending on what physical media is used, so your connectors and wires and things, it represents them differently with modulation. So that's where like the voltages and cabling comes in as well. Now, coming into the fiber and UTP, these are the cabling. Now, I'm going to start with UTP because we're probably familiar with it. It stands for unshielded twisted pair. But normally, we just say Ethernet cable. Technically, Ethernet can run over a lot of these. It can run over fiber, it can run over UTP, and things like that. But UTP is the basic use case for this. And that's just represented by voltage. So, if it's a 1, it'll be a positive voltage. If it's representing a 0, it'll be a negative voltage. That's how that works with voltage. With fiber, it's light. So it would have light be on to represent a 1 or off for a certain time to represent a 0. So that is how that works. With RG cable, that is radio grade cable. That's used in cable networks for your cable TV, for things like that. And that's also represented by voltage. And of course, your radio is represented by radio waves as well. But as well, you have your connectors here. So those are your RJ45. If you have a desktop in front of you, or you're plugged into a UTP cable, Ethernet cable, look down there and you'll see an RJ45 cable. Terminated right on the end there. And for the next one, if you still have a landline, see the RJ11 jack. So if you look on the back of that, you'll see a little jack. It's a little bit smaller than RJ45, but it serves the same type of purpose. F connectors are on the ends of your RG cable. So that if you look at the back of your cable TV, you'll see one of those. Back of your cable modem, you'll see one. Just make sure not to bend the little straight piece there, the stinger, if you take it out to examine it. And make sure to turn your modem off first. ST, that's a type of fiber connector. MTRJ is another type. LC is another type. There's many types of fiber cable and fiber connections. So, with all of that we talked about with the OSI model, the OSI model was made in the 1970s to apply to any network. Telephone system, computer networks, obviously. Any kind of network you can think of could be used and designed by that. But later on, we decided that the main network we're using this for is IP-based networks, so computer networks. So we made the TCP/IP model, and that is the most standard one you'll find when you read about it and things like that. This is having 5 layers. There is another variation, I think, that has 4. I believe the 5 layer is the most current. The application is, again, where the protocols are, but you just roll layers 7 through 5 into 1. Alright, so it starts at layer 5 basically. You'll still use the same layer numbers to describe a problem. If I have a routing problem, I would say, hey, I'm on the phone, I have a layer 3 problem. Something like that. But with the transport layer works the same, the network works the same, the data link and physical works the same. And another important point, back when networks were first being developed, you actually had to have the same vendor computer to talk to that other computer. So Apple computers could only talk to other Apple computers using Apple Talk. DECnet equipment could only talk using DECnet. There was IPX. But we eventually settled on IP and IPv6 for our routed protocols. So that is why we have this layer, and the main ones you'll see are IP and IPv6 at layer 3 when discussing it. Other than that, though, it does work completely the same. It's just a little bit more simplified. But now we need to finally talk about sending and receiving and how the model operates in that capacity. So encapsulation is the first thing, and this is when we're sending information. So we have the 7 layers, and at the top here, we're going to use that application protocol, HTTP. And at this point, there is the PDU. The PDU is just the protocol data unit. It's just how we talk about data as it moves down the layers. And it's data at layers 7 through 5. And it then goes down to layer 4. And obviously each layer does its thing to it up here, but it goes down to layer 4 and then gets turned into a segment. And then TCP or UDP, whatever the application is programmed to use at the protocol at layer 7, will put on its header and source port and destination port number, among other things, but that's the basic of it. And then the transport layer sends that segment down to layer 3, and layer 3 puts its header on there, and then it's called a packet. But that's where it adds the source and destination addresses to be routed across the networks. And again, layer 4 is where it added the source and destination ports. But layer 4 on its own doesn't know how to route it across the network, just knows how to talk between ports. So layer 3 knows how to route, so that's why we add those addresses there. And then layer 2 adds the frame. And that frame, remember, is those MAC addresses that sends this information between computers. So the frame has actually 2 parts, and I believe it's called frame because it frames the information all together. Now the header has the source MAC address, the destination MAC address, preamble, and other things like that. All the other information from layer 7 through 3 is in the middle. And then at the end, the frame has a trailer. And this trailer has the CRC 32-bit checksum to make sure it wasn't corrupted. All these layers do have a checksum, but at some layers with some protocols, it is optional. But that is how we send information. And when the receiver needs to process it, he goes through the process of de-encapsulation. So starting at the bottom here. So de-encapsulation, after they take the bits, the voltage, the light, the radio waves, whatever layer 1 media you're using, they take that off and we find a frame. And you want to look at your MAC address first. So once that computer knows that destination MAC address is his MAC address, he's going to strip off the layer 2 information here. And then he's going to bring it up to layer 3. Now, what they'll look at layer 3 is the IP address. So they're going to look at that destination IP address, and if it's his IP address, it's going to strip it off, look at layer 4. As well, though, if it is a switch at layer 2, an Ethernet switch, will only look at layer 2 and send it back out at layer 1. Alright? And again, also if it's a router at layer 3, it will only look up to layer 3 at the IP addresses and then send it back down to layer 2 and then send to layer 1 and then send it on its way. But as well, if it's a firewall that's doing filtering, even your computer does this, it will also look at layer 4, but it would send it down as well. But that's the basic of how those 2 devices would work at those layers. But anyway, after we find out it's for our IP address, we're going to send it up to layer 4. And we're going to look at our destination port number there, see if we have anything that we expected to have information for. If we do, though, if we're a server, if we're a client, we're going to de-encapsulate up to the protocol. This could be HTTP, this could be SSH, Telnet, any number of those protocols at layer 7. And it just sends it up, processes it, and then if we want to send a reply back, we do this, and then we do that, and then that, and then that. So it does that, thousands of times a second, all the time. But that's how computer networks basically send information back and forth, and that's the models we use to represent it. So from here, though, I'd recommend you go to Wikipedia, search OSI model. You'll see a lot more information than I was able to fit in this video. With all of that, I do hope you enjoyed this video, and I hope you got some use out of it. I'm Tyler with T-Tech, and I will see you later.